Okay, so as I was saying, I wanted to split the last video up because the one question already took so long, and this one looks like it's going to be another tough one. Oops. So it was log x times root x. Presumably the the log is only on the x, not the root x as well. Although maybe not. Maybe it's log of x root x. How would we know the difference? I could have put the root x in front of the log to be clearer. But I don't think it makes sense to be log of x root x, because then the question is way too simple then. So it must be what I was doing a moment ago. Y equals log x times root x. Okay, so the derivative, that will be 1 over x root x plus log x, then over 2, and then 1 over root x. Bring down the power, reduce the power by 1. So then that's all over 2 root x. And then that's 2x plus x log x. Oh, I didn't say that in the last video, did I? Oh, but this simplifies. I should be simplifying first. Because I can change this into 1 over root x. Yeah, okay, so that's a simpler form. This is all over 2 root x, 2 plus log x. Okay, so when is it positive? It's when 2 plus log x is positive. Okay. So that's e of minus 2, isn't it? So that's when x is more than e power minus 2. Okay, so that's a start. Increasing when x is more than e power minus 2. And then decreasing when x is less than e power minus 2. Okay, b. Okay. Local min and max, so that would be when x is equal to e power minus 2. And that would be a minimum, because it went from decreasing to increasing, I guess. So c was the concave up, concave down, so we'll need the second derivative. So that's the bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom. Bring down the power, 2 times a half is gone, reduce the power by 1, so that's 1 over root x. We know in this question that x has to be positive, so we don't care about the denominator, so we'll just look at the top. So that'd be 2 over root x minus 2 plus log x over root x as well. Oh, well, that's really nice. That's just going to be log x over root x. And again, this is positive. So we want the concave up first. So that would be when x is more than, when does this go negative at, when x is before 1. So when x is more than 1, and then concave down, when x is between 0 and 1. Okay, and D inflection point at when x is 1. Okay, let's have a look. Let's see, I'm curious if I'm right for this one. Log x, square root x. Right, okay, so what are we saying? Let's check. Increasing one more than e power minus 2, which looks like that value there, all right. Yes, that does look like 1 over e squared, doesn't it? Yeah, yeah. So increasing and decreasing before that, so correct and correct. Minimum at that point, definitely correct. Concave up when it's more than, what did I say? 1. No, concave up when it's more than 1. And concave down between 0 and 1. No, it's... something's gone wrong here. Maybe it's with my second derivative. Or maybe I have to zoom in more. That's a concave up 0 to 1. Did I make a sign mistake? I wonder if this is now... Okay, now let's see. Zoom out. Yeah, it's concave down, so I just have it concave up, concave down. I have it backwards. Because I missed the minus here. That's why. So yeah, that's why it's the backwards for me, because I lost a minus on the previous one. So down and up then, inflection at 1 then. Okay, now we're correct. Nice. Nice. These don't look as bad, I guess. We can do that next time.